Hello, my name is Paul Kovalov. I'm a registered professional engineer in the state of New York and the world's foremost authority on weave grounding and bonding technology. Welcome to Weebisodes. This is a short series to teach you a little bit about the solar market and some of Burndy's renewable energy products. Now, some people might be familiar with solar in the sense of seeing modules installed on rooftops or maybe seeing it on the news. We'd like to take you through some of the solar terminology so that you can get more familiar with the market. This is an array. This is a module, this is a module, and this is a module. These are all the basic building blocks of a solar array. When sunlight strikes the cell of a module, a DC voltage is generated between the positive and negative leads of the module. This is an array. It's a number of solar modules connected together to generate power from the sun. That power can be used to then power lights, appliances, industrial equipment, or stored for later use. Modules need to be supported when they're installed in the field. There's plenty of wind loading and snow loading to account for, and racking systems are what accomplish this. Now, a racking system is basically a structure made out of metal usually to support modules and make sure that they stay in place and oriented at the right angle towards the sun. Grounding is important for several reasons. First, it allows the array to detect and mitigate ground faults. Secondly, it prevents people from getting inadvertently shocked when they reach out and touch something that they think is not energized. If somebody servicing the array goes out and touches a component that's not properly grounded, there is a chance that current can flow from the array into the person and into ground. They effectively become the ground path. There are several ways to prevent ground faults. One is to follow the industry best practices when installing solar modules. Another is to use proper wire management devices. These can be cable clips, unwraps, cable trays, and the like. What wire management does is it prevents cables from getting pinched between module frames and rails or other pieces of the structure. This could cause ground faults by breaking the insulation on the cable and letting current run through the racking system instead of through the conductors. The last major component of a solar power plant is the power electronics. This includes your DC to DC converters, microinverters, charge controllers, and inverters. What these components do is they take the DC current produced by solar modules and turn it into AC current that's usable in residential and industrial applications. Charge controllers and battery banks can be used in off-grid applications to store electricity produced during the day for use at night. Now that we've talked about the major components of solar arrays, let's take a moment to talk about the scale of applications. There are residential, commercial, and utility scale applications. These all depend on the power consumption needs. Typically see pitched roof mounts in residential scale installations, pole mounts in commercial scale installations, ballasted roof mounts in commercial scale installations as well, and ground mounts in utility scale installations. Well, that covers our brief introduction to the solar market and some of its key components. Join us next time when we talk a bit about grounding and the Burndy weave washer technology. Thank you for watching.